Happy Friday, everyone. First Friday of the new year as well. We've got dry air in place across our area, and I always like to start off with surface analysis as we dive into what's coming because it's a good idea to see what's going on currently and how it matches up with the modeling as it does go into the future. It gives you a good idea if we're on track or if something's already screwed up in the modeling. And you'd be surprised how many times we get initializations that are wrong. It happens quite frequently, and usually that messes up that run or shifts something in the forecast and just makes it unreliable. So sometimes you get to toss out a whole list of model runs when that happens. It doesn't happen terribly often, but it does happen. So as we look at the surface analysis here, we'll jump right into it. We've got dry air across the southeast, and you can see all the winter storm warnings in place. You got ice storm warnings going, you got winter storm watches, you got winter storm warnings, you got winter weather advisories all through here. Great Lake heavy snow advisories and winter weather advisories ongoing there as well. A good sign that hey, winter is here and a winter storm is coming. You can already see what's taking shape. We got our storm system out here. It's basically going to eject out, and we're going to get a low pressure system to develop about here, somewhere around there. And then that should ride basically like that. A little piece of energy is going to split off to the south here as well and leave a trailing boundary. But for the most part, all of the cold is on the north side of this system. The modeling about a week ago was actually favoring the southern piece of energy as opposed to the northern piece of energy, which is why we had the modeling suggesting that maybe Tennessee would get all of the snow as opposed to into Kentucky and the Ohio River Valley. But typically in the short range, we see a northerly bias in the models, and in the long range, we see a southerly bias in the model, meaning that typically things are too far south in the long range, and usually in the short range, things are too far north. So that's just bias that shows up from time to time, and that's what we've got going on. So as we put this into motion here, I'm going to zoom out a little bit. You can see our big storm system starting to work in to the Pacific Northwest, and that is what's going to be working across basically like this and then coming out. So good rule, really, if you're into forecasting or you're into looking at what's coming now. Typically where low pressure systems come into the coast is usually where they want to leave the coast. I don't know why that is. It's just usually how it plays out from time and time again. Typically, wherever it comes in is where it's going to leave. So if you get a storm system to come in here, sometimes you get it to dive like that, but it still exits somewhere around there. It's just the way it goes. So if you want cold and snow across the southeast, you want this kind of pattern, but you also want a piece of energy basically to come on board somewhere around here. Or even better, if you're in the Gulf of Mexico, you want a piece of energy to come on board here. Because then you get something to transfer like that, and that's how you get snow to deposit across the deep south. It's because much like our storm system at the moment that's cutting across the country right here, where it was the north side of that system, that was where all the snow is going to fall. And on the south side, that convergence zone where the warmer air is going to try to push in, that's where you're going to see ice and sleet and all kinds of nastiness. So the closer you are to the low track with colder air in place, the closer you are to warm air that's trying to intrude in. The further away from that low, the colder, drier air is still going to stay in place, but the less moisture you're going to have. So there's a finite zone that you're going to fall into if you want heavy snowfall to happen. And typically that's underneath the 700 millibar low. So if you move up in elevation as far as the surface maps go, because that's mostly what you see when we're showing you weather, is the surface elevation. If you go up and check the 700 millibar level, that's usually where the heaviest snow does fall. So if you ever are into forecasting and you want to know how to forecast snow and where the heaviest snow is going to fall, track that 700 millibar low, go right underneath it, and that's usually where you're going to see it. And you can look at thicknesses, meaning the temperature difference between the layers for where you're going to see those convergence areas. So anyways, to move on away from our surface analysis here as we go into the forecasting, I will say we're going to start off with basically the system that's coming in. And then I'll talk about the system next week and kind of the cold wedged in between. And I kind of laugh every time I say the cold because it is really, really cold air that is coming in. And cold is always relative to average. We have a lot of transients here, or people that have moved here from other locations, transplants, whatever you want to call them, and people that are going to stay here for a short period of time and move somewhere else. We only see freezes about 5 to 7 times a year. So having 5 freezes in 7 days, pretty rare. Having freezes for extended period of time where we're getting weeks of potential freezes coming our way, Very rare. So yes, I know if you're from New York, Minnesota, Michigan, up north where they're getting ready to get slammed by snow and cold, this isn't that cold for you. However, we shouldn't have that here. Temperatures should be in the 60s this time of year, and overnight lows should be in the 40s. So yes, this is cold relative to our average. The same way as if Minnesota was 15, 16 degrees below zero for this time of year, that would be cold. It's all relative. It's relative to average, and that's what we mean when we're talking about cold and when we're saying those kinds of things, because everybody's got a different standard of cold. It's really just what is an area used to. So let's break it down here as we go forward. We got colder air reinforcing as we speak. That should lead to a relatively cold night tonight, but as we zoom all the way through Saturday into Sunday, we're going to see the winds shift back out of the south, and in doing so, we'll bring that warmer air back. You'll note that we are going to bring enough energy across the southeast that we see a line of storms developing off to our west. We'll have to see how much energy that can hold as it moves into the panhandle. It is possible we could be talking about marginally severe storms as they do work in. Some of the modeling is suggesting that the colder air undercuts it, and then all we're talking about is just scattered showers we're going to cross our area as that colder air filters into our area. The other thing to note on Monday, it's going to be windy, and we're going to see those temperatures falling throughout the day. We'll see highs probably in the early morning hours in the 60s, and by noon, we'll fall into the 30s. By 1 o'clock, we may recover to about 41 to 44, but the wind is going to be howling out of the north and west, 15 to 20 miles an hour, so 44 with 20-mile-per-hour winds. It's going to feel quite chilly, and as we go forward through that night, how about even our coastal areas challenging the upper 20s? Yeah, it's going to be very cold. Add in a little bit of wind and it'll make it feel much, much worse. And the cold pattern just continues. So from there, where you saw the snow and ice working across basically the Ohio River Valley and north of the Ohio River or along the Ohio River and then back across West Virginia, the next storm system actually does eject out of the south and west. So I'm going to back up here and move this forward so that I can zoom out, and then I want to draw on this a little bit. But we're going to see a piece of energy eject from out here. So by the same math that I was just talking about, that should work across the Gulf of Mexico and then exit the same areas. So this big push to have it throw up to the north and then come across, bringing warm air into our area, yes, it's possible because we have an upper level low that's going to be working in at the same time. There's a ton of pieces of energy here at play, and there's a whole lot that has to go on. There's going to be phasing that the models aren't picking up. There's not going to be phasing that the models are suggesting. Overall, we're in a very cold pattern, and we're going to see a piece of energy eject out of Southern California, really south of Southern California, the Baja of California, and then across Mexico into the Gulf of Mexico. This pattern typically favors a Gulf slider or something staying in the Gulf of Mexico and then working up the East Coast, as opposed to something ejecting. If the upper level low outpaces this low piece of energy down here, then we get a little ridge to develop across the southeast that pushes this piece of energy off to the north, and then guess what? We're just cold rain because the cooler air is still at the surface, but we're just throwing warmer air over the top of us. Most of the southeast is dealing with cold rain in that case. If the upper level trough actually outpaces our surface low, say it gets stuck back here for whatever reason on the piece of energy, or it comes out a little bit slower and this works a little bit faster, then we could have a reinforcing shot of colder air already in place, and that would help to make this more of an overrunning event. Vice versa, if this upper level piece of energy is much, much slower and we just eject this out and we have a much flatter pattern with colder air already in place, then you can also bring frozen precip back. So what I'm saying is we're still a long way out, and there's a lot of pieces of energy still at play, and there's a lot of things that are going to trend and change on that forecast for the end of next week. Basically, looking at the upper levels, if you want, again, going back to the forecasting, if you want to get good at forecasting, look at the 500 millibar vorticity. That's going to give you a good idea of how things are working together, how things are phasing, and how they're going to eject or move across the country. That gives you a much better concept of where storms are and where storms are going to be, as opposed to just looking at the surface level, which is really not much of a driver of the weather overall. The mid and upper levels, far more influence than what's going on at the surface. So if you want to understand what's going on with the pattern, you can watch that 500 millibar vorticity level and see how those pieces of energy work and interact with each other. If you're into forecasting, if you're not, you can just watch someone like me that's giving a discussion talking about the possibilities that are coming up. And yeah, it's possible we could see things trend back. I would think that if we're going to see cold air in place and we're going to see an overrunning event, we're probably talking more or less about ice at this point, just based on the orientation of the system that's coming in and how our cold is being transported in. If we get this low to sink far enough south, and it does work somewhere between Tampa and Miami, and we have that upper level trough somewhere, say Montreal to Charlotte or back across Detroit, and that helps to sling moisture back to the north and west, that's the best case scenario for snow around here. And even if we miss out next week, this cold pattern is sticking around for a couple more weeks, so we may have another opportunity. So if you're a snow lover like me, yes, I do love the snow. I don't really want it because I work it, and I don't really want to have to deal with that here. I don't want to have to work in the snow. I'd rather play in the snow. But if you're a snow lover like me and you get the opportunity to play in the snow as opposed to working in the snow, then you can be excited too about the pattern. But understand at the moment, really, we have a whole lot still to go on. And the same thing across the southeast. If you love snow and you want snow in central Alabama, back up into Tennessee, going through the Carolinas as well, don't give up on this storm system just yet. We've got a lot of pieces of energy at work. It's still very possible that we could see things end up further off to the south. Basically, everything past next Wednesday is pretty uncertain at this point until we see this piece of energy really starting to develop on the south side of California, so the Baja. Once we get that down there, then we'll start to have a better understanding. But even then, until it starts to eject out, you can get big model swings, especially with a southern system here. And there's really just not a ton of data being collected through here. So going back to the initialization, sometimes things get messed up, and typically it's when data or a storm system is coming out of an area that is relatively data free, as opposed to something that's coming into the Pacific Northwest. Once that's onshore, we've got plenty of data on it. So yeah, that's where we're at. We'll do another update, but cold is on the way. Be ready for the hard freezes that are coming next week, and then we'll see how things trend as we go toward the end of next week.